With the main pieces of our notation in mind here for how we talk about inequalities, we can actually look at solving them, where we're going to start the solution process here in the same way we did with equations by looking at our most basic kind of inequality, the linear inequality. Here we have things of form ax plus b is not in some way equal to 0. Either it is less than, greater than, at least, or at most equal to 0. But we have that extra bit of ambiguity there with the inequality, so when we're getting our answers, instead of looking for a thing that just has one solution, like with a linear equation, we're going to have a whole window of possibilities to look at instead. But before I get to that, I do want to illuminate one small subtlety that's very important for how these things work that hopefully you've seen before, but it's good to be reminded of, which is when we talk about multiplying through negative values, that does the same sort of thing as flipping the inequality. And to understand that, we're going to look at, like I said, a basic example here, something like negative x is less than or equal to 1, which is almost a solution, as it were. It almost tells us what we need to know, but it's not quite there. And to understand how we could get to our final answer, well, we could multiply through by -1, but again, something a little bit weird happens. So to see what happens, let's take this the long way and just rearrange everything. We like to get x's by themselves without any coefficients, so here I'm going to add the x over, and then what I'd be left with is 0 is less than or equal to 1 plus x, and then I'm going to isolate that -1, and we will have -1 is less than or equal to x. And we'll see here that besides the fact that I flipped the whole thing over just generally, if I was going to multiply through a -1 to end up back where we started, that would also flip the order of that inequality. So just bear that in mind. Anytime you throw a negative sign through with a multiplication, it also rearranges the order because it's the same as adding and subtracting the same things to both sides as a rearrangement. But anyway, let's get one more complete example here to understand what we can do and how we can find our solutions for linear inequalities. So for our first example, we want to solve and graph the solution to 2 minus 3x is less than or equal to 5. So our process here, excuse me, is, as I said, very similar to what we would have done in sections 1.1 and 1.2 in terms of being able to solve an equation, except now we're looking at an inequality. Here, what we would want to do is take our pieces. 2 minus 3x is at most 5, at most or less than or equal to means the same thing in this context. Then, well, we want to get that x by itself. So we're going to subtract over a -2. We'll have -3x is less than or equal to 3. And to prove a point here, I'm just going to divide over the 3 first. I'm going to divide over the -3, but I want to make sure we're still following along. We'd end up with -x is less than or equal to 1, just like we saw last time. So we could add and subtract all things over to rearrange it, which would result in the sign essentially being flipped in the middle. Or we can multiply through a -1, which does the same thing. And we'd end up with the value x is at least -1. And so we have the solution set here that x is greater than or equal to -1 with a graph like this here. And if we wanted to express that as a set instead, we could say something like -1 to infinity with a closed square bracket for the -1 and open on the infinity side, because we never technically include infinity. Infinity is not really a number in this context as much as a marker of the fact that it just gets bigger and bigger forever and ever. Or if we prefer the set builder notation, the set, oh boy, that's a bad curly brace, of x values such that x is at least -1. Again, these mean exactly the same thing, just whether we want to write it as an interval or as a set that represents an interval, really. Anyway, dealing with any sort of linear inequality like this, not super complicated, so let's look at another kind of thing we can do here where we have a little bit more to be careful with in terms of what's called a compound inequality instead.